So in this case, we are going to look into the basic features of a hyperbola, which is our inverse graph, all right? The hyperbola. A hyperbola is of this shape, all right? We'll find out when we've got our x-axis and y-axis, maybe there is an asymptote where the graph is limited. Let's say the graph cannot pass through the y-axis. Also, it cannot pass through the x-axis. So we can have one piece of the graph in this quadrant, another piece of the graph in this quadrant. All right, that's basically on a condition where A is greater than zero, when A is a positive value. This is the format of an inverse function where x is in the denominator. It can be 3 over x, all right, 2 over x. You can even you have 2 over x plus 1, 2 over x squared. As long x is in the denominator, that's the inverse function. So when our A is what? Positive, when A is greater than zero, you're going to have one piece in the first quadrant, another one in the third quadrant. And when our A is less than zero, another piece will be in the second quadrant, and another piece will be found in the fourth quadrant. So by joining points, you produce something of this nature. This is where A is less than zero. This one in what? In red. In the second and fourth quadrant, where A is greater than zero in the what? First and third quadrant. So the rest, guys, is the same solutions, depending with the graph, how it is, considering the area, this and that, all as we had before. So for us to understand, I'm going to quickly go through a question that I'm going to demonstrate here. And with that question, use it to answer any other questions that you're given on a hyperbola or the inverse function. Then we are given copy and complete this table of the graph of y is equal to 6 over x. All right. That is, we've got missing values, minus 6. When x is minus 6, simply put minus 6 here. 6 divided by minus 6, that's what? Minus 1. When x is minus 4, put minus 4 here. So 6 divided by minus 4. 6 divided by negative 4 is what? Minus 1 comma 5. So when x is minus 4, y is minus 1 comma 5. When x is 2, just put a 2 here. 2 into 6, that's 3. When x is 3, 3 into 6, that's a 2. When x is 5, 6 over 5, that's 1 comma 2. It's 1 comma 2. So this will be 1 comma 2, something like that. So this is our table values, and you're given 2 centimeters to represent 2 units on each axis. All right, draw this graph, x taken from minus 6 up to 6. So that is 2 centimeters to represent 1 unit, 2 units. Then the y values, the minimum is minus 6, maximum is positive 6. All right, so let's see from minus 6 up to 6. 2 centimeters represent what? 2 units on both axes, on both. So that's 0, 2, 4, 6. Okay. -2, -4, -6. And -2, -4, -6. Then 2, 4, 6 also on the y. 2, 4, 6. So that is it according to what we're given. 2 centimeters to represent 1 unit. So you mark your points just like before. Minus 6 versus minus 1. When x is minus 6, y is minus 1. Minus 1, that's in between 0 and minus 2. So that's where they meet. You mark a point, all right? So that's minus 6, minus 1. Okay. When x is minus 5, we need minus 1 comma 2. Minus 5 here and minus 1 comma 2. Here you can see that if this is minus 1, each box actually represents 0 comma 2. 0, 2, 4, 6, 8, 1. So minus 5 and minus 0, 2. That's simply here in between minus 4 and 6. And you just need one box going down, only one box. All right. So that's it. Minus 4 and minus 1, 5. Minus 4 and minus 1, 5. Minus 1, 5. So that's actually in between 1 and this. All right. Why is it these values, guys, are going the other way? This was minus 1, 2. Minus 1. Okay, think here, guys. Where did I put my minus 1? Minus 1 here, minus 6, and minus 1. There, I represented minus 0. This is, guys, you see now, that's 0, 2. This is 0, 2. This is minus 1 here, then minus 1, 2 here. Okay, I'm wondering what's happening now. All right, then minus 4 and minus 1, 5. Okay, let's correct that. Minus 4 and minus 1, 5 in between. That's minus 1, 2, 1, 4, 1, 6. So minus 1, 5 will be in between minus 1, 4 and 1, 6 in between. Okay, then another one, so just complicated points, but that's how you're gonna be given these. Just work out as they are. Minus 3, minus 2, minus 3 versus minus 2. That's gonna be here when y is minus 2, x is minus 3. Okay, then minus 2, minus 3, minus 2 and minus 3 here, minus 2, minus 3. Okay, another one, minus 1, minus 6, minus 1, minus 6 here. So when x is minus 1, y is minus 6. So we can see that on the negative region, this is what we have. And moving to the other side, there was supposed to be 0 here, but x cannot be equal to 0. You cannot have 6 over 0. That's infinite, undefined. Actually, this one is what? Undefined. So meaning to say, where x is equal to 0 is an asymptote. So y axis is a what? An asymptote. Our y values cannot be equal to that. I mean, x cannot be equal to 0. So you move on to another point, 1, 6. All right, when x is 1, y is 6. 1 versus 6. Okay. 2, 3. When x is 2, y is 3. Then 3 versus 2. All right, 3 versus 2, 4, 1, 5. 4, 1, 5. This is 1, 1, 2, 1, 4, 1, 6. So 1, 5 in between 1, 4 and 1, 6. Okay. Another one that we are given is going to be 5. And according to what we are given, it's 5 and 1, 2. 5 versus 1, 2. So 5. This is 1, 2, just one box on top. Then 6 versus 1, 6 versus 1. So that's it. That's what you're given. So using these points, you're going to definitely join them and have the hyperbola. So like as you can see, our value of x here, I mean, this a is positive. A is greater than 0 positive, so you must expect a shape like this. Okay, one in the first and another one in the third quadrant. So from the points, this is what you're gonna have. Here you join these points. There's this one, the 6. So you're going to join the points. Okay. So that's it. You move on this side. You join these ones which are on this side, all of them as they are. So that's it. That's a hyperbola. One piece on the other hand, another piece on the other hand. So sometimes, depending on the points, you can just have points on the one side, just one piece like this. So you work with that one. But in this case, there are two pieces, one on the other hand and another one on the other hand. So on the drawing part, that's how you draw a hyperbola using what? The table of values. All right. Anyways, let's proceed. Use the graph. We're going to proceed with our graph to find the area bounded by the what? Bounded by the curve. So area bounded by the curve, that is our curve, this one or this one. We do not know which part are we going to work with. So here they say bounded by the curve, so it's either this one or that one. Let's move on. X is equal to 2. The line X is equal to 2. So this is the line where X is 2, a vertical line that is going up. X is equal to 2. All right. X is equal to 3. So where X is 3 in between here, X is 3 going up. That is where X is what? 3. And the x-axis and the x-axis. So this is our x-axis. So we can see that the region that is bounded by the curve, the graph, and those lines, it will be this region in between that is left here, that is bounded, that is covered by these lines. This one, this is the region that you're talking about, covered by all the lines and the curve bounded in between by all the lines that we presented and the curve. So this is the region. All right, so that was it. Remember, the line was x is equal to 2, another one x is equal to 3. So this is the region. So you count the number of boxes in this region. So here is gonna be 50. Is that so? 25. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sorry, guys, how am I counting now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 50 boxes here. 51, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then here I'm going to combine this and say 12. So that's 62 boxes that I have there. So the area, remember, number of what? Boxes over 100 times unit square. Number of boxes over 100 times the area of the unit square, which is 2 times what? 2 times 2. All right, area of unit square. So how many boxes? 50 plus 12, that's 62 over 100 times the area of the unit square, 2 times 2, that is what? 4. So that's it on our calculator. 62 divided by what? 62 divided by 100, which is 6,2. Then you multiply by 4. So that was going to give us 2,48, 2,48 square units. So our area is going to be 2,48 what square units from what we are having from that region that is bounded, right? We're going to have something like that, right? So you just needed to count the number of boxes in that region. 50, just count, guys, 52. So it's going to be 62 over 100 times 4. Okay, so that is what we had. I don't know what you're obtaining. And the gradient of the curve, where x is what? Minus 3. The same we talked about the gradient. So you simply use the tangent where x is what? Minus 3. Minus 3 to the point of tangency. So this is our point of tangency. We draw our tangent, which touches the curve at that point. Okay, so that was simply the aspect of what? Of the gradient. So something like that. So here, the points that we are going to use. So this is now item 2. The points, one is the point of tangents where x is what? Minus 3. All right, as we are told where x is minus what? Minus 3. So that's minus 3 versus minus 2. minus 3 versus minus 2. We look for another point which lies on the graph. Okay, we're going to look for any point. Okay, 1, 2. This one, guys, let's see. This is it, something like this. Something like that. So here we can use this 2, minus 2, and 0, comma, and it's gonna be 2, comma 3, something like that. Okay, so what did I do now? So anyways, guys, the way that you see, it was supposed to be like this. Does it make a proper tangent? Yes, guys, you must use a ruler properly. So if you use a ruler, it just follows a direct. But here, guys, you see the way that I'm using. So anyways, that's it, something like that. Oh, this one, 0 versus minus 4. So let's use this one. It's on the tangent 0, minus 4, or maybe it's somewhere around minus 3, comma 9. So let's just use 0 and minus 4 and determine our gradient, the change in y over the change in x. So x1, y1, x2, y2. So that's y2 minus y1 minus 4 minus y1 minus 2 over x2, 0 minus what? Minus 3, 0 minus minus 3. So simplify this. It was going to give us minus 4 plus 2, which is minus 2 over what? You add, this is going to be 3. So that's minus 0, 0.666, like that, which is minus 0, 0.7, right? To one decimal place, depending with the instruction that you're given. If you are told one decimal place, use one decimal place. So that was minus 0, 0.7. They can just mark plus or minus. The gradient is marked plus or minus 0, 0.3 units or 0, 0.2, but mostly 0, 0.2 units. So in within plus or minus that was going to give you a gradient. All right. So that's our item 2. You simply apply direct as before. The gradient at a certain point, use that point. On the same axis, draw the line y is equal to x. So you can use the table of values to draw the line of y is equal to x as it divides the graph into 2 equal parts. Or you can simply what? Use the table of values where x and y are simply the same. This is a straight line. So where x is minus 4, y is minus 4, and x is 0, y is 0, and x is 4, y is 4, because x and y, they are the same. So minus 4, minus 4, we mark a point, 0, 0. 4 versus 4, we mark the point. Then with these points, we are simply going to join them, produce what? A straight line using our ruler. Remember, table values, 3 points are enough to have the straight line. So that's our straight line of y is equal to what? Of y is equal to x. Okay? So from there, you are now given, hence, it's a continuation, this one, hence, solve the equation 6 over x is equal to x. So 6 over x is our hyperbola, the one that we had here, that we drew before, 6 over x. What about this one that is equal to x? It is the straight line that we drew of y is equal to x. So they are simply telling us that these two graphs are equal. Y is equal to 6 over x and y is equal to what? Y is equal to x. They are equal. So where do we find our solutions? At the point of what? At the point of intersection. So we simply consider the points of what? At points of intersection. That's where our solutions are, where the two graphs intersect. The graph of what? Y is equal to 6 over x, and the graph of what? Y is equal to x. So where do they intersect? That's where our solutions are. So they intersect here and also intersect here. So what are the x values at the point of what? intersection of these graphs. This one it was supposed to correspond to something like negative 2,4. All right, so here's 2, here it's going up to the x-axis. That's negative 2 comma 2. This is 2 comma 2, 2 comma 4, negative 2 comma 4. And this one also 2 comma 4. So those are the solutions now that you are going to consider on your item 3 to say our x values at the point of intersection. It is minus 2 comma 4, or x is equal to this side was also going to give us what? 2,4. So that's how you answer questions based on what? On solutions. You will simply consider the points of what? Intersection of the two graphs that you are given on the question. So you work it like that. So you see, guys, hyperbola or the inverse function is just one of the easiest graphs. Just need to follow the concept so that you do not miss any other aspects. All right, just follow all the steps in drawing, understanding the shape, and so forth. But that is it till we meet again.